Hello, everyone. My name is Edward Hartnett. I work for CIRES at the University of Colorado, assigned to NOAA NCEP. And I would like to, first of all, acknowledge my collaborators from the University of California, Irvine, Charlie Zender, who is the author and maintainer of the NCO tool set for NetCDF files. At UCAR, Ward Fisher and Dennis Heiminger, the NetCDF team at Unidata. And at NCEP, my colleagues Hang Lee, Brian Curtis, and Kyle Dorheiser have all helped me with various forms of NetCDF compression. Excuse me. There are several backend formats that are now available when you're writing NetCDF data. There's the classic formats, which is where it all started, and there's 3 of those available. They do not offer any compression within NetCDF. You can, of course, compress the file after you write it. Then there is the HDF5 backend, which does offer zlib and SCIP compression, and mostly I'll be talking about zlib in this presentation. And recently, Dennis added to NetCDF support for ZAR as a native format, so now you can write and read NetCDF data from the cloud, and it supports its own compression. Everything I say for the rest of this talk is mostly going to apply to this middle box here, the NetCDF HDF5 files. Excuse me. Now, NetCDF has, of course, C and Fortran layers, and NetCDF Java as well, and it has offered zlib compression since NetCDF 4.0 was released, I don't know, about 15 years ago now. And this, of course, uses the HDF5 built-in zlib compression features. Charlie Zender and I, about, I don't know, 2 years ago, a year and a half ago now, we started the Community Codec Repository Project, the CCR project. And our goal there is to have a home for community-based, community-developed new compression methods which can work with HDF5 filters, which are a very exciting feature and have been supported in netcdf-c since 4.8.0, so several years now. And this work, the talk of quantization and bit grooming, comes directly from that CCR project. So what is a quantization? It's really very simple. You have floating point arrays. There are the 32-bit or 64-bit. And they can represent 7 or 14 digits of precision. And that's more than is commonly needed in earth science data. So the goal here, or the plan, is you define what your required precision is, and then excess bits in numbers are set to 0s and 1s, alternating. Due to the long runs then of 0s and 1s in the quantized data, compression is more effective and the output is smaller, which is the goal. Here's an example from the Unified Forecast System at NOAA, which writes a file which uncompressed would be 36 gigabytes and compressed is 6 gigabytes. This is atmospheric model output. Now that is a tremendous level of compression, and much more than you can achieve with just zlib alone. So we developed the CCR filter, the BitGroom filter in the CCR project, and it still is there. It's well-tested code. But there is a shortcoming to that approach, which is that it uses HDF5 filters. Well, the only action is when you're writing data. Readers do not need to do anything to the data to unquantize it. They just read it. But because it's a filter, you must install it on the system that's reading the data as well as the system that's writing the data. And that is a significant ask, because if you have a data producer like NOAA and we start to use Quantize on our data, and then every single user of NOAA data has to install the filter to read it, even though the filter does absolutely nothing on read, that's a problem. Another problem with the filter approach is that NetCDF Java has no access to filters. And so it cannot apply or use the filter, and therefore such data would be completely unreadable to netcdf Java without major work in netcdf Java. So that was a bummer. So we came up with this idea instead. We put the Quantize code right into the netcdf-c library. Now it is no longer a filter. It is part of the native library. It's currently used in the library only by netcdf4 HDF5, but we do plan to use it for other backend formats as well in the future. Classic formats, of course, will benefit because when the BitGroom is applied, then you compress the resulting data file, it will compress a lot smaller. And NCR, of course, will benefit because if it can compress the data more, then that's less data to send out onto the cloud, and obviously that's going to make everything much faster and cheaper. So that's a win. So we expect those to come along, but for now, it is for netcdf4 HDF5 files only. Since it is implemented in the C library, all BitGroom data is now immediately readable by all existing netcdf-c and Java versions. So there's no compatibility issues at all. So you can start producing this quantized data, and even people using old versions of netcdf will still be able to read it quite easily, and there will be no compatibility issues. So currently this is working. It's merged into the main branch of netcdf-c. I have netcdf Fortran pull request up, which word will merge at some point, and then it will be in the next release of both netcdf-c and netcdf Fortran. Excuse me. Okay, well, there's a new function to support this, NCDEF-var Quantize, and you can see the prototype there on your screen. It takes the NCID, which is the file ID, it takes the variable ID, quantize mode, and a number of significant digits that you want to preserve. Just like turning on deflation, you must turn this on before you write any data or finalize your metadata rights. It has to be turned on before any data is written to the variable. Once you write data to the variable, you are not allowed to turn it on. It only applies to float or double. Otherwise, if you try and apply, you get an error. And currently, there's only one quantize mode available in C, Quantize BitGroom, which uses BitGroom. I should have, but I just realized I did not put a reference in this paper. Charlie Zender has a paper that he wrote which explains BitGroom in great detail, and that can be found on the CCR GitHub page. There's a reference to it if anyone's interested in exactly how the number of significant digits translates into how many bits to wipe out. Okay. So that is how you turn on Quantize for an NetCDF variable. And there's an Inquire function which allows you to say, is it turned on for this variable? And it works just like the inquiry functions in NetCDF. All of this is implemented in this function in nc4vars.c, which is a key file in the netcdf4 implementation. It's the same place where if you were converting data type, like if you were converting data from integer to float or something, there's a big function in which that conversion takes place. Well, while that is happening, or instead of that happening, if there's no conversion, quantization happens as well, if it's turned on. Okay, here's a little example from one of the tests. Here we create a file with nccreate. It's an netcdf4 file. We define one dimension, and then we create two variables. One is a float, and one is a double. Okay, then we call NCDEF-var Quantize for both variables. So here's var ID1 and here's var ID2, and we turn on Quantize BitGroom, and we say 3 significant digits. That's a constant defined to 3 in any test. So we're just saying we're only keeping 3 significant digits of both of these variables, and then you write data as normal and close the file. So the only thing you need to add is these def-var quantize calls for each variable that you want to turn on quantize for. So this is very similar to deflate. And actually, now that I see this, this is a dumb example, because turning on Quantize without then turning on deflate is really quite pointless. So in this example, I should have turned on deflate immediately afterwards for each file. Okay, a few details. There's a fill value in netcdf, and if you have set a fill value and you use some of those values in your data, they will not be quantized. If you don't set a fill value, then that will apply to the default fill value. In other words, if you use a fill value, that value will not be touched during quantization. Only the non-fill data will be quantized. It works well and is tested with parallel I/O. And as I said before, it works currently with netcdf-4 HDF5 data, and it is planned to be added to ZAR and possibly the classic formats in future releases. Charlie Zender is working on even more efficient and effective quantization schemes instead of BitGroom, and they may be added in future releases. And when you turn on Quantize for a variable, it adds this attribute to the variable that you've turned on Quantize for. Quantize BitGroom number of significant digits. And this is an integer attribute that is set to the number of significant digits that you specified. So when you do an NC dump and you see this in the attributes, that's how you know that that particular data has been quantized, and this many significant digits has been preserved. Okay, I just got 2 more slides, and they show some of the improvements that are available. So let's talk about a final file size, first of all. This comes from a program, Test Compressed Power, which is part of the netcdf-c distribution. It's a test that happens to use parallel I/O, but there was also the same with sequential, very similar. So here we have a file which is about, on the y-axis here, we have file size. It goes up to 8 gigabytes. And then on the x-axis, we have my different things that I tried. And when I do nothing, no compression, no BitGroom, nothing, the file comes out to about 7 gigabytes or more. If I then turn on zlib compression at these 3 settings, 1, 4, and 9, it shrinks the file down to less than 3 gigabytes. If I then turn on, in addition, quantization, we see that it shrinks the file even further down to almost 1 megabyte. So as you can see, applying quantization just about cut your final compressed file size in half, if not even slightly better. Okay, so what used to be a 3 gigabyte file is now 1 gigabyte. It also improves write performance when you turn on quantization, and this makes sense because when you quantize the data, you're making less work for the compression algorithm, so it can do its job faster. And since the data are compressing more, you're actually ending up doing less actual disk I/O. So that also causes it to be faster. So here is the write rate in megabytes per second on my Unix workstation. With no compression, I get about 600 megabytes per second. When I turn on zlib, obviously it dramatically slows down the write rate to like a third or a sixth of the original rate. But when I then turn on quantization, my write rate goes back up. And so here you see with zlib of 1, which is a great setting for your zlib, you should usually be using 1, not any higher numbers. And for significant digits, you see that I get much better write performance than if I just compress alone. And that is my final slide. Does anyone have any questions?
Great, we have time for the question.
So on the one slide where it showed the compression ratio with and without BitGroom turned on, the S-zip seemed to be worse with BitGrooming. Is there a reason for that?
I do not know what the reason for that is. I cannot say. Actually, I found that to be surprising as well. So I don't quite know why S-zip would be worse with quantized data than non-quantized data. It doesn't seem like it should be, but So no, I'm sorry, I can't explain that. I don't use SZIP much, and it's not used in use at NOAA. So I did not pursue that very thoroughly. Any other questions?
Yeah, one other related, did you try using the HDF5 shuffle filter also, where it kind of pulls off the lower and upper bytes and then compresses each of those separately?
Yes, I have tried that, and that does make a small difference in the results, but I just left it out of this so as not to complicate things further.
Thanks.
Hey Ed, this is Ellen at MathWorks. Nice talk. Question, the new quantized methods, those are in NetCDF 481, right?
No, 481 has been released, right?
Yeah.
Yeah, no, they went in after the 481 release. So
Okay. So the next release.
yeah, they're in the main branch of the GitHub repository now. So they're
Got it.
what used to be called the master branch, and they will be in the next release. And I hope that will be before the end of the year, the calendar year. But that's up to Word.
Okay, thanks.
However, we have a paper on this at the AGU, and so I'm hoping that we can get a release out there so that when people see the paper, there's actually a release that's already out there. Any other questions?
So I may have a naive question about fill value thing. So
Yeah.
when the user doesn't specify fill value, is it still using the default fill value, or can it just go the default be more like don't fill the values? Because we have seen a couple of talks that were talking about you have to turn on the never fill to get good performance with HDF5 and NetCDF.
Huh, that is interesting. I will have to look into that a bit more.
Mm-hmm.
I do not think that you should get much better performance by turning off fill node.
So when we are so this was one use case we looked at, which was parallel IO, and they were using NetCDF4 with HDF5. One process was doing the fill value, like filling the value slowly for almost 90% of the overall IO. And then they did the IO, all the processes participated.
The fill value handling is a bit of a weak point in the CDF, actually, because there's no way there is no way in that it is indicated in the data that you turned off fill mode.
Mm-hmm.
Right? So we always assume that if you don't specify the fill value that you're using the default fill values,
mm-hmm.
but we really don't have a way of specifying, no, we're not using any fill values. Mm-hmm. So that's a bit of a weakness, I guess, in netcdf-c, but
mm-hmm.
I don't know how to fix it. So I think we just need to look.
Yeah, I mean, by calling another function, okay, don't do that, don't fill, solve the problem, which is easy, but have to make that extra call.
Well, that just turns off it happening.
Yeah.
But it does not indicate in the file anywhere,
right,
that you turned it off.
Mm-hmm.
Which it should, if you think about it, right?
Mm-hmm.
It should have written an attribute or something to say this variable was written without a fill value.
Yeah,
but it does not.
Mm-hmm.
So that's a bit of that's a blind spot. I don't know what to do there. But in quantization, in all cases, it will assume that fill value is in use, either when you set or the default. However, it won't change the end result. It's just that those values won't be quantized.
Right.
But they'll still be in the file. And so if you're not using them as a fill value, you still see them as data. And that's fine.
Okay.